Hey math fans, welcome to section 1.2.3. Let's get started. A population of mice quadruples every 6 months. If a mouse nest started out with 2 mice, how many mice would there be after 2 years? Write an equation and then use it to solve the problem. Before we get started, here are the key concepts for this section. Please write down, please memorize this formula right here. Y is equal to A times B to the X. This is going to be your general form for an exponential equation. Each of those variables is really important. First of all, let's take a look at the A. The A is probably the easiest to start with because I always begin with, this is your initial amount. So let's say you're starting off with 100 things and they're growing exponentially. Well, you would put the 100 right where the A is. B is the base. And if the base is 1, that's a starting point. If the base is 1, exactly 1, nothing's going to happen. This thing's not going to grow and it's not going to get any smaller. We call it exponential growth and exponential decay. Neither of those things will happen if B is equal to 1. The minute it goes above 1, it's exponential growth. The minute it goes below 1, like 0.99 or 0.98, it's going to be decay. Now, pay close attention to this last form down here where you're dividing by a number t. That's when it's growing exponentially every so often, every month or every year or every 2 months. And we'll kind of deal with those problems in the guided practice as they come along. Let's get started. Here's the general form for an exponential equation. However, we're going to have to change it slightly because of this. It says that the population of mice will quadruple every 6 months. So we're going to have to take care of that every 6 months part of it. So watch closely. The nest started off with 2 mice. That goes first. That goes in for A. And then it's being quadrupled. So we're going to be multiplying that by a base of 4. It's going to get 4 times as big. Now here's where we're going to have to change this part of it. If X is equal to the number of months, then we would put 24 up there. However, this would be quadrupling every month for 24 months. That's not what this problem says. So what we're going to have to do is say that it's going to happen every 6 months, and there's where that t comes into play. So really the equation is y is equal to 2 times 4. 24 divided by 6 is 4. Now be careful here. Do not multiply these first. You're going to raise 4 to the 4th power first and then multiply. 2 times 256 gets you the 512 mice, which is the answer to this problem. Now, some people might do it a different way. Could you do it this way? Y equals 2 to the 4th, 2 times 4. And we're going to basically say X is the number of years. If we say that X is the number of years, and we have to think about it, if it's happening every 6 months, how many times a year is it happening? Well, it's happening twice a year. This is okay too. And then you have to think, well, wait a minute, it's going to be 2 years. So 2 times 2 is 4. y equals 2 times 4 to the 4th power, and you get the same answer. Either way will work. Please remember, though, these are two separate types of problems. Are you going to have x be months or years? So it depends. If you're going to use the book's formula, you need to make sure that you're using the correct units to divide by. Both of these have to be months. If you're doing a different unit, then you can do it this way. In sporting tournaments, teams are eliminated after they lose. The number of teams in the tournament then decreases by half with each round. If there are 16 teams left after 3 rounds, how many teams started out in the tournament? The first thing you want to do is start with the general form of the exponential equation. Y equals a times b to the x, where a is going to be the number of people or things you're starting off with. B is going to be how quickly these things are increasing or decreasing. Remember, if b is equal to 1, nothing's happening. And then x is the amount of times that it's being multiplied by that number b. And then y is really what you have after that certain time period. In this particular problem, they're saying that after the time period, there's 16 teams left over. So actually y is equal to 16 here. And then it's asking how many teams started out. So we don't know what a is. But we do know that the number of teams in the tournament decreases by half. So B becomes really easy when you are dealing with quadruple, triple, half, because whatever that number is goes in for B. So if these teams are being eliminated, half the teams are being eliminated every round, then it'll be 1/2. And so x will be the number of rounds, and it says that the number of rounds is 3. Now, we don't need to worry about dividing by t. It doesn't say, for a certain time period that it is, like in the last problem, every 6 months, something's happening, or every 4 months, or every 2 minutes, or every 3 rounds, or whatever. So we're just going to go every round and solve from here. Remember, when we are 1/2 to the 3rd power is really 1/2 times 1/2 times 1/2, which is 1/8. And then, in order to solve this, we're going to multiply both sides by 8, or 8 over 1. And what that will do is leave us just with a, which is what we want. But that means we have to multiply this side by 8, or 8 over 1. Which leaves you with 128 is equal to A. So what does A again represent? That's the starting number in this tournament. There were 128 teams, and then half of them were gone the first round, and then another half of that half was gone the second round, and by the third round, it leaves you with the 16 there. Kind of a working backwards problem, but that's how you do that. Example 3 says the population of a small town is increasing at a rate of 4%. If there are currently about 6,000 residents, how many residents will there be in 5 years at this growth rate? Because this problem has a growth rate, we're not going to use this one. Instead, we are going to use the formula that has the growth rate built in. Now remember, if you don't want any growth or any decay, it's actually going to be just 1. But we want this thing to grow at a certain percentage rate, which is 0.04. So that's basically, we're going to be using, let me write the equation out. So for growth rate, you want to use y equals a times, instead of b, you want to have the 1 in there, because the 1 would mean it's not growth, no growth or decay, plus the percent rate would go in for R, and then you have T for either the number of months, or in this case, T is equal to the number of years. And it's good to define that before you get started. So let's plug in some numbers. Remember, A is the number that you're starting with, the initial amount, and you have 6,000 residents. 1, that's got to be in there. Please don't just put the rate in there. You got to put 1, and then if it's growth, this population is going to be growing. We're going to add, now don't put 4, put 0.04 because it's 4%. And then T is the number of years, and the problem specifically says 5 years. And all we have to do now is simplify this, and we have our answer. Now your calculator is going to crunch these numbers for you, and you're going to get 7,299.917414. Now remember, what are these? These are residents. You can't have 0.91741 of a resident. So I would say at this point, it's okay to just round up and say, approximately 7,300 people are going to be in this town after 5 years. You want to reduce the size of a picture to place in a small frame. You aren't sure what size to choose on the photocopier, so you decide to reduce the picture by 15% each time you scan it until you get to the size that you want. If the picture was 10 inches long at the start, how long is it after 3 scans? So let's take a look at this. Because there's a rate, and let me circle that rate, which is 15%, like the other one when it was 4%. We're going to use that same formula again, y equals A times 1, either plus or minus R. In this case, we are reducing, okay, so it's going to be minus R. It's going to be less than 1 because it's going to be getting smaller. And then we're going to put X be the number of times that you're doing it, the number of scans. So remember, A is your starting point, and the starting point here is the picture was 10 inches long, so that's what the 10 represents for A. 1 minus 0.15, do not put 15 in there. You'll get a negative number, and then you're really going to get a weird answer. So it's going to be 1 minus 0.15, and that's going to all be raised to the 3rd power for the 3 scans. And after simplifying, you get 6.14125, which you can estimate around to 6.14 inches. And that'll do it for this section. We'll see you in class.